R Programming Simulation Part 3.
Another application of simulation on statistical analysis is on regression model. Let us run a simple linear regression model from iris data. Let's say sepal length is the dependent variable and petal length is the independent variable. We use the LM function to come up with the coefficient, the beta null and beta 1. LM is a linear function. So let's say we put here reg model. LM equal to sepal dot length and then versus the independent variable is the petal length, and then data is from iris. So the coefficient that we obtain here is beta null equal to 4.3066 and then the dependent the slope equal to 0.4089. Let's say we want to simulate the data. Let's say if I use only let's say if I simulate for one data. To simulate the data, we need to simulate the petal length and then the error term. So how to do that? Okay, we get the summary of the mean of petal length and the standard deviation of the petal length. Okay, so this one, the mean and the standard deviation of the petal length is equal to 3.758 and 1.765 respectively. And then we also determine the statistic for the residual. So to get the residual, okay, we use this function. Actually, this is come from here, summary of the reg model. Okay, so this is the fully a detailed analysis of the regression model. But if we want only the residual, okay, so we can put the dollar sign and the residual. So this is the data of the residual. Okay, so we get the analysis, we get the mean and the standard deviation for the residual. See, mean of this one. Let's say we give name here, residual or just resi. Run. So we compute the mean of the resi and the standard deviation of the residual. Okay, so this is the mean and the standard deviation. So it's a very small value of mean and the standard deviation. Okay. And then after that we simulate, okay, the petal length So we put here petal sim. Okay, let's say we use the set dot seed of 111. Okay, so petal sim come from the normal distribution, mean equal to here. Let's say we want to, actually the total data is 150, so we simulate 150 observation, mean equal to 3.758, and then the standard deviation 1.765. Okay, run, and then we run the residual. Sim receipt is equal to the, we assume that the data come from the normal distributed 150. Okay, mean equal to 0. Okay, in this case, if you, as you can see that the actually this is 0.0000, so it's a very small zero. Okay, and then with the standard deviation, this is actually 0.4057, so I choose a 4 decimal point here. Okay, and then run. Okay, and then sepal sim. Okay, so sepal sim, I use the sim parameter here. Okay, here to obtain the sepal sim 4.3066 plus 0. So this is the slope 0.4089. Okay, multiply by the petal sim, and then plus the residual. Okay, residual pun saya letak set seed 111. Paste, run. Okay, so I have petal sim, the residual, and the sepal sim. Okay, so let's say I run simulated data based on the simulated petal sim here. Okay, sim model is equal to the LM, which Y is the sepal sim, and the independent variable is the petal sim. Okay, run, and then let's see what is the coefficient that we get. Okay, so I get here the beta null is equal to 3.4428, and then the slope is equal to 0.6388. Okay, which is quite close to the actual one. Okay, so as I mentioned, this is only first attempt of the simulated data. If you want to do a simulation, you need to simulate more than one. So to do that, okay, you can run in a function. Okay, so let's say I put here set 111. Okay, and then come up with the matrix. Okay, sim 100, matrix, okay, number of row 100, number of column equal to 2. So we want to generate 100 set of data, and then we run the simple regression model, and then you will get a set of 100 set of beta null and beta 1 respectively. Okay, so that's why we put a 2 column here. Okay, so from here, okay, we try to simulate the petal sim, simulate the error, and then come up with the sepal sim. Okay, and then based on the result, okay, we try to get the coefficient. Okay, so we just copy this one. Click copy. Okay, so seed 111, so 100 observation, 100 set of data. Okay, each 100 set of data consists of 150 observation. Okay, so we want to come up with the coefficient values only. Okay, so we run this one. Okay, so actually this is the value of the sim 100. Okay, we will get the value of beta null and beta 1 respectively. So there are 100 of them. Okay, and then let's say we want to find the mean of beta null and beta 1. We can use the apply or the apply function. So in this case, let's say I use the s apply. So the data is the sim 100, and then I want to compute the mean. Okay, oh sorry, oh what I saying, sorry. I think I better use the apply function here. The apply, I only want the second column. I only want the mean for each column. Okay, so I will get on the average. Okay, the beta null is equal to 4. The simulated beta null is 4.313, and then the beta 1 is equal to 0.40722. Okay, the original one, this one, okay, this is the coefficient value, and then this is the beta null, this is the beta 1. Then as you can see that the actual and the simulated, okay, are close. So therefore the assumptions pertaining to the distribution of the error terms are satisfied. Okay, you can also, let's say if you want to simulate for 1000, so you can change here into 1000. Okay, and then let's see what happened. Okay, so as you can see that the simulated value, okay, become closer to the actual one as we increase the number of the number of data in a simulation. Okay, so that's all for today.
Thank you for watching.